welcome to LearnCity. My name is Praise and today we'll be talking about the trigonometric graph. We'll be talking about the trigonometric graph where we'll be talking about the sine and cosine of trigonometric graph. Now, what is trigonometric graph? Trigonometric graph is described as the line representation of angles. The trigonometric graph is described as the line representation of angles. Now, the procedure for drawing the graph of trigonometric functions is similar to that of algebraic functions. Now, remember that when we were talking about the quadratic formula, quadratic equations, where we talked about drawing graph of quadratic equation. Now, the procedure for also drawing graph of trigonometric functions is very similar to that of the algebraic functions. A table of values is constructed with selected values of the independent variable and the values of the dependent variable calculated from the given function, in which we form a table whereby we have the dependent variable and the independent variable. Now, the independent variable is displayed on the axis while the dependent variable is displayed on the coordinates. Now, smooth curves are used to join points on the graph. Now, the points on the graph, lines are used to join them, or in some cases, curves. And now we'll be solving two examples on the sine and the cosine graph. Now, the first example says, draw the graph of sine theta and cos theta for values of theta ranging from 0 degrees to 360 degrees. So where we have our theta ranging from 0 degrees to 360 degrees for sine theta and cos theta, which means we'll be drawing two different graphs in this question. We'll be drawing for the sine theta and the cos theta. Now let's do for the sine theta first. Now we form a table where we have theta and we have sine theta. So from 0 degrees to 360 degrees, we start from 0 degrees, 30 degrees, 60 degrees, 90 degrees. We use the interval of 30 degrees, 120 degrees, 150 degrees, 180 degrees, 210, 240, 270, 300, 330, and 360 degrees. Now, for sine 0 degrees, we have it to be 0. For sine 30 degrees, we have it to be 0.5. For sine 60 degrees, we have it to be 0.87. For sine 90 degrees, we have it to be 1. For sine 120, we have it to be 0.87 degrees. For sine 150, we have it to be 0.5 degrees. For sine 180, we have it to be 0 degrees. For sine 210 degrees, we have it to be minus 0.50 degrees. Now, this is where the sine and the cosine, the quadrant comes in. Now, where we figure out that at the first quadrant where we have it to 90 degrees, our sine is positive. On the second quadrant where we have it to be 180 degrees, our sine is positive. Now, on the third and the fourth quadrant, our sine will be negative. So, on the first quadrant from 110 degrees, we have it to be minus 0.50 degrees. At 240 degrees, we have it to be minus 0.87 degrees. At 270, we have it to be minus 1. At 300, we have it to be minus 0.87. At 330, we have it to be minus 0.50. And at 360, we have it to be 0. So we draw the graph where our x degree is our y, where our y line is our sine theta, and our x line is our degrees. So we have our graph to be something like this. So here we have 0, we have the space of 0.5, we have this to be 0.5, we have this to be 1, we have this to be 0.5. We also have this plus to be minus 0.5, minus 1, minus 0.5, 1.5. So here we can have 50, 100, 150, 200, 250, 300, 350, and 400. So when we have at sine 30, we have it to be 0.50 degrees. So our sine 30 will be around this point. At sine 60, we have it to be 0.5. Okay, at sine 0 degrees, we have it to be 0. So we have this point here. Then at sine 60, we have it to be 0.87. So at 0.87, we fall around this side. We have 60. Then at sine 90 degrees, we have it to be 1. At sine 120, we have it to be 0.87. And sine 150, we have it to be 0.5 degrees. At sine 180, we have it to be 0. At sine 210, we have it to be minus 0.5. At 240, we have to be minus 0.7. At 270, we have it to be minus 1. Then at 300, we have it to be minus 0.87. At 330, we have it to be minus 0.50. And at 360, we have it to be 0. So we bring a line. So we have so this is the sine graph. We have this to be the sine graph. Now, moving to the cosine graph, the same way we also did our cosine, our sine, we also do our sine the same way. So, for our cosine, we have tan and cos theta. So, we have 0, 30, 60, 90, 120, 150, 180, 210, 240, we have 270, we have 300, we have 330, and we have 360. So for our cos theta, at 0 degrees, you have it to be 1. At 30 degrees, you have it to be 0.87. At 60, we have it to be 0.5. At 90, we have it to be 0. At 120, we have it to be minus 0.5. At 150, we have it to be minus 0.87. At 180, we have it to be minus 1. At 210, we have it to be minus 0.87. At 240, we have it to be minus 0.5. At 270, we have it to be 0. At 300, we have it to be 0.87. 330, 0.5, and 360, we have it to be 1. So we plot our graph. Where we also have the same way. Two hundred, 250, 300, 350, and 400. So at 0, we have it to be 1. At 30, we have it to be 0.87. So we have it to be somewhere around here. At 60, we have it to be 0.5. At 90, we have it to be 0. At 120, we have it to be minus 0.5. At 150, we have it to be minus 0.87. At 180, we have it to be minus 1. At 210, we have it to be minus 0.87. At 240, we have it to be minus 0.5. At 270, we have it to be 0. At 300, we have it to be 0.87. At 350, we have it to be 0. At 330, we have it to be 0.5. Then at 360, we have it to be 1. So join the graph. So here, this is our cosine graph. This is our cosine graph. Now, moving to the next example. Next example says, using an interval of 30 degrees, draw the graph of y equals to cos 2 theta minus sin theta. For 0 less than or equals to theta less than or equals to 180 degrees. So use the graph to determine the minimum value, the values for which cos 2 theta is equals to sin theta, and T, the solution of cos 2 theta minus sin theta, which is equals to minus 1. Now, what do? We form our table. So while forming our table, we have our theta to be here, we have our cos 2 theta, we have our sin theta, and we have our y. where we have our theta to be 0, 30, 60, 90, 120, 150 and 180. At 0, our cos 2 theta is 1. At 30, our cos 2 theta is 0.5. At 60, our cos 2 it will now be 2 times cos 60. We have it to be minus 1.0. At 90, we have it to be at 60, we have it to be minus 0.5. At cos 30, we have it to be minus 0.5. At cos 90, we have it to be minus 1. At cos 120, we have it to be minus 0.5. At 150, we have it to be 0.5. And at 180, we have it to be 1. Then for sin theta, we have it to be 0.0. We have 0.5, 0.87. We have 1.0. We have 0.87. We have 0.5. And we have 0.0. Now, for both sides, we have 1, where we have cos 2 theta minus sin theta. We have this to be 0. We have this minus 1.37. This is minus 2.0. This is minus 1.37. This is 0. And this is 1.0. So now we draw our graph. So drawing our graph, we have something like this. Here we have 0, 0.51. We have 0.5. We have 1, 1.5, minus 0.5, minus 1, and minus 1.5. So we have 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. So at 30, we have our y to be 1. We have our y to be 1. Okay, at 0, we have our y to be 1. And at 30, we have it to be 0. At 30, we have it to be 0. At 60, we have it to be 1 minus 1.37. So we can just stand this part. At 90, we have it to be minus 2. So here we extend it to minus 2. At 120, we have it to be minus 1.37. At 150, we have it to be 0. And at 180, we have it to be 1. Hence, we draw our graph. So we have something like this. Now, this is the graph for y equals to cos 2 theta minus sin theta. So the first question says find the minimum value when y is equals to 2. Find the minimum value where y is equals to lowest. The minimum value of y. So the minimum value of y is minus 2. The minimum value of y is minus 2. So we have minimum value to be minus 2. Our minimum value is minus 2. Now the second question says find the value for which cos 2 theta is equals to sin theta. Here we have cos 2 theta and sin theta. At cos 2 theta, what do we have? We have it to be 30 degrees and 150 degrees. So the second answer says at 30 degrees and 150 degrees. That is where our y cos theta at 30 at the cos 2 theta and sin 2 theta. So on our y-axis, our cos theta cot theta at 30 degrees and our sin theta cot theta at 150 degrees. Now for the solution of y equals to cos 2 theta minus sin theta, which is equals to minus 1. So we have our cos 2 theta minus sin theta, which is given as minus 1. Now it is given at where cos 2 theta and sin theta intersect at point y. It intersects at point y. Now where y is minus 1, where y is minus 1, this is where y is minus 1. So where y cot theta is minus 1, we have it to be this point and this point. So when we bring it upward here and we bring it to this side, when calculating it, we have it to be 52 degrees or 128 degrees. It is known as 52 degrees. If being drawn on a normal graph, then these angles will be easily located at where cos 2 theta cut at line y and where our cos 2 theta is equals to minus 1. So at our point minus 1 here, we'll find where our numbers intersect the curve. So we have it to be 52 degrees and 128 degrees. And this brings us to the end of our class on the trigonometric graph, on the sine and the cosine graph. And we'll be seeing you in the next class. Thank you.